Okay, welcome to part 2 of Introduction to Breadboards. And in the last video we discussed, or in the last section we discussed the breadboard layout. We're actually going to go ahead and build a very basic circuit in this lesson. So we're going to go ahead and start adding some components. And what we're going to do is use a 2-input AND gate to turn on an LED. So let's go ahead and look for our 2-input NAND gate. Now you should learn this from your lecture and your lab activity. So what we're going to do is, I already know the name of the chip, and it's 7405 or 7408, I believe. And there it is. It's a quad 2-input AND gate. So you go ahead and click on that. Now remember that I said that chasm separates these sets of connections from these sets of connections. So what I want to do with all these chips is put it right across that chasm like this. And I will do it right there. And just click out here. And so the reason I'm doing that is because I need all of these pins separated from each other, because remember, each one of these are separate. And same thing down here. And I need this side of the chip separated from this side of the chip. So right now each one has an individual connection to its own node, and nothing is being shorted out. And what I'm going to do is go ahead and connect an LED and a battery source so we can actually turn the battery source on. So let's go ahead and type in, we can either type in LED, or we do have this thing here for LED and optoelectronics. And we see that we have these LEDs. So let's go ahead and grab this 5mm LED, click there, and I'm just going to put this right over here to give me some room so I can connect things down here. Okay. Now I need a power source. So I can see the battery is right there, so let's just go ahead and click on that. And let's click on these 2 AA batteries. This should be enough to actually run this circuit. Oops. Do that. Put this right. Put it right here, somewhere in the middle. Okay, so what we need to do now is just go ahead and start wiring things up. So remember I said that this whole row up here could be ground, and the next one here could be power. Same thing down here. I can do this whole one as ground and the next one as power. So when you get these boards and they're color coded, the one to the far right is normally the ground. It'll be blue. There'll be a blue line all the way across showing it's continuous, and there'll be a red line on this side showing that these are all connected. And so you normally want to put the red to the power and then the blue to the ground. Same thing on this side. The ground's going to be there and the power is going to be on this side facing down. But let's go ahead and start connecting things. So if you look up here to the very top, we have wires. So we can go ahead and start connecting some wires. I'm going to go ahead and start connecting my power. So, and I'm going to use the color code that we normally use for jumpers. So I got red. And one point, this is what the wire looks like, what the size of the wire is. That's good enough for our simulation here. So I'm going to go ahead and start from there, snap it, and then I'm going to click right here. Now notice that all those things light up there, because this is telling me that when I connect it here, all of those are going to be this same connection. Now typically all of these should also be connected together, but this simulator is not connecting the entire row together. So let me just get out of there. Okay, so now I want to go ahead and connect the ground to a ground strip. So let's go ahead and pick, where is the black? We can normally use black as the ground, so I'm going to go ahead and do this and put that right there. Okay, oops. And there we go. Now we have power here. All of these are power, and these are ground. So I can actually use this as ground, and this is power. So let's go ahead and wire up our LED. So an LED, we've already discussed this in lab. You should know that one side needs voltage, and the other side has to be grounded. And so I'm going to go ahead and ground our cathode right here. And I'm going to use, hopefully I'm still in the right color. Black, right there. Okay, I can do that. Oops, I didn't mean to do that. There you go. So remember, all of these are connected together. So it doesn't matter if I connect it to that point, that point, that point, that point. It's all one piece of wire underneath. So it's basically like connecting it to this pin of this LED up here. Okay. Now the other thing is I want the LED to be connected to the output of an AND gate. And I'm not going to show you the input of what's inside this chip here. We can actually look at the schematic or the pinout in lecture. But what we're going to do is we're going to connect pin 1 here, pin 2, which is both inputs to one of the circuits is actually etched and built inside this chip. And pin 3 over here should be the output. Right? But before we do that, let's go ahead and wire up the chip itself, because this needs power and it also needs a ground. So the ground, if you look up the schematic for this 7408, is on this pin right here. So you can see that little notch right there. This is pin 1, 2, 3, 4, 5, 6, 7. And then we go this way, 8, 9, 10, 11, 12, 13, 14. And let's zoom in real quick so you can, hopefully they're labeled. There they go. There they go. I don't want to really move this. There we go. But you can see G and D right there. So that's ground. So I want to actually put ground to here. So let's make sure we got wire. We get a black wire. And I want to connect. And it doesn't look like it's connected very well. Let me do this. Right there. Okay. Now it's connected on there. Okay, you can see they're in actual holes. So now let's go ahead and get the black wire. And I can use any of these right here. So I'm just going to do this first one. And I'm going to connect it to the ground. I could go straight here. I probably should just to make it look nicer. All right. There we go. So now this is grounded. And it also needs a power source. So let's go ahead and minimize that. So remember the power source is right up here. Let's go ahead and make that with a red wire. And let's just do right there. And I'm going to go straight here. Because remember, you see all those things lighting up in pink? That means I can hook it up to any of those connections right there. So I've done that already. And okay, there we go. So this chip now has power and it's grounded. This LED is grounded. And I need the output of this LED to go to the, the input of this LED to go to the output, come from the output of this chip. Let's go ahead and use different color wiring so that we can keep our wires color coordinated. So remember I said input 1 and 2, those are the inputs to the chip. And this pin 3 is the actual output of the chip. So I'm going to go ahead and go from pin 3 right there. And I'm going to go to anywhere on this node right here. So I'm going to go right up there. That should be fine. Okay, that's good. So now you can see that the output of this chip is actually connected to the input of the anode of this LED. It goes through the LED, and the cathode of the LED is actually grounded. Grounded with the same ground as the chip, and it's grounded with the same side of the negative side of the battery. So now what we need is just 2 inputs to this AND gate. We said 1 and 2 are inputs. So if you remember from the lecture from digital circuits, you need 2 highs with an AND gate to get the high output. So in other words, in order for us to get like a 5-volt out to get this LED to turn on, I need a high here and a high there to activate that circuit. So let's go ahead and show you 2 different scenarios here. I'm going to use, let's see, a good color. I'll try purple. All right, purple is going to be 1 input. And I'm going to go from there to there. Okay. So we're going to leave pin 1 at high. So it's always going to be with the positive side of the battery. And I'm going to use another one. Let's try. We haven't used blue yet. Okay, there's blue. The second input right here. Now, I can connect it to ground, which would be 0, or I can connect it to over here, the positive side of the battery source. Let's go ahead and do the ground first, right? Like that. Okay. And we are actually done with our connection of this circuit. Let's go ahead and run the circuit by hitting the power here. And what happened? Nothing. Because we have a high, or what is this? 1.5, about 3 volts, a little about 3 volts here, and we have 0 volts here. But we need 3 and 3. We need 2 high voltages, or 2 highs, or 2 ones, and pin 1 and pin 2 for this thing to turn on. So let's go ahead and remove this and move it to the positive side. Turn that off, and let's see if I can move it without having to rewire it. Let's do this. And remember, I can hook it up anywhere here, but I'm just going to do it right over here to keep it close. Okay. And let's do that. So now these both of these inputs are with the positive side of the battery, and so that means that that AND gate should be active and should output that 5 volts to the LED and go to ground and turn on. Let's see if we did everything correctly. And the LED is on. Fantastic. All right, so this is how we use a breadboard. And if you need to come back and review the video, please do. Remember that all of these are connected together. On a real breadboard, they're all connected together. On the simulator, it looks like just half of it's connected together. And this entire row here is all connected together. So I can make this entire thing ground all the way across. And I can make this bottom row power by hooking up power here. And so I can tap into power anywhere there in that node, like a junction box. And over here, the same thing. This whole row up here is ground. And the second row underneath it is power, because I've connected that there. I could have easily connected this to the very top, and that would have given me power up on top as well. And then the chip, if you haven't taken or you're not taking digital and you're just looking at this video to understand how to use a breadboard, that's perfectly fine. You don't even have to know what the chip does, but at least we know how to connect things on a breadboard. But thank you very much for your time, and let's move on to the next part.